Using the pins present on the Raspberry Pi GPIO pins on the top of the unit, in the picture there you see a Pi Juice hat, but it essentially piggybacks the GPIO pins, so the pin numbering would be the same. Using the pinout diagram that I linked to in the video description, you want to find the power, ground and input pins. So there are different pin numbers for each of these, so you want to be providing 5-volt power to each of these sensors. You want them connected to ground, and then you want their signal wires, in other words their out wire, connected to any one of the I/O pins. So in my case I've selected pin 14 as the signal pin for the DHT11 sensor, and pin number 21 for the signal for the soil moisture sensor, so the third wire of the soil moisture sensor. With our sensors connected, we're now ready to retrieve sensor data using Python. Once we have our Raspberry Pi and our sensors set up and connected to the GPIO pins on the Pi itself, and we are remoted into the Pi using SSH, and we've installed all of the other prerequisites, one of the first things to do inside of our virtual environment that we're going to be running the project in, we need to import the library for Adafruit's DHT. So that's the library that Adafruit Industries has made available for the DHT11 sensors. So the temperature and relative humidity sensor requires its own library to be imported. You can receive the source code and information on it from their GitHub page, which I've linked to in the description below. So alternatively, you can just get the commands to install it using pip3. So making sure that your virtual environment's already activated. Once you're inside of your virtual environment, you want to pip3 install Adafruit_DHT. In my case, it'll say that it's already satisfied since it's already been installed. But as soon as that's installed and configured, then you essentially have all of the initial requirements that you'd have for this first iteration. So today we're going to print the latest sensor results right into the terminal on the Pi. So before we do that, we first need to import the various libraries that we're going to use. So it's the DHT sensor, GPIO, and time, so that we can add a timestamp to each of the readings that we look at. So first we import rpi.gpio. Now VS Code will give you a warning about rpi.gpio being an unknown module. As far as Windows is concerned, it is an unknown module, but obviously you'll have that pre-installed on the Pi, so when you run this Python script on the Raspberry Pi, you won't be receiving any issues. Now we import Adafruit library so that we can interact with the DHT sensor, and we import the time module for timestamps. Now we want to declare and initialize our sensors first of all. So the soil moisture sensor that we're using is called a YL69. We're going to be using it in its digital mode. It's a small voltage that represents either a 1 or a 0. So it's either a high or a low that you receive from the sensor, and you can calibrate it on the sensor itself. You set the threshold for it to decide when to say this is enough moisture or it isn't by switching over from 1 to 0. 1 is actually, in this one's case, a low output, and a high output, which you'd expect to be the 1, is actually the 0. So it's kind of reversed like that, but essentially when it switches, you want to receive that information. So first we'll do so for the DHT, because that's not a digital sensor. We're going to receive analog input from the DHT11, which means it'll actually give us a reading to say temperature in degrees Celsius and relative humidity in percentage. Nice thing about it is that both of those readings are sent simultaneously, and you can just strip both of those values from the input that you're receiving from the sensor. So all of that information is already there, even though you're only initializing and declaring one sensor. It's a DHT11. If you used a DHT22 sensor, which is very similar but has a higher accuracy, I believe, so it costs a little bit more. But if you were to be using a DHT22, then you'd specify DHT22, where I specified 11. And we want to say the pin that we've connected it to. Now I've connected it to power and to pin 14. So we'll tell it which channel the sensor is on, in this case 21, being GPIO pin number 21. And for this one, because it doesn't have its own library to give the Raspberry Pi information about the sensor, we have to initialize the pins themselves, as in the mode that we're using GPIO in, and we have to do a GPIO.setup, telling it that the pin we're working on is YL channel, the variable we've just declared above, and it's a GPIO.in, meaning it's an input on that channel. Because the GPIO stands for general purpose input output, they can be used as both input and output, so you have to specify, in the case of the DHT11, it's using the Adafruit library to tell it that it's an input and tell us all the information about how the sensor works and what to do with the data received. But on the soil moisture side, it's really just almost a generic switch, so you have to specify and tell it that we're going to be listening on this port for an input, because the port 21 could of course be used for an output or for something else as well. So you have to expressly tell it that that is what it's being used for. We've got our sensors declared and initialized. Now we want to see if we can get the information from the sensor outputs. So we declare some variables for each parameter that we're looking at. Both humidity and temperature are coming from the DHT11, so we use one of the functions from the Adafruit DHT library called read and retry, and we specify that it's the DHT sensor, which is the sensor we've already initialized up top, and it's residing on DHT pin, which we've declared above as pin 14 as well. Now the moisture reading, because we're going to be receiving one of two values, either a high or a low, we essentially want to tell it what to do in each scenario, and for that we're going to use an if statement. So if our GPIO input on YL channel so we've declared what our moisture reading is. Now if that moisture reading is a GPIO.low, what do we do? As I said, it kind of works in reverse. I had to figure that out the hard way. It works in reverse, whereby it gives a low output if there is sufficient moisture. So when it switches due to moisture being present on the two legs of the sensor, it actually outputs to a low state. So if the output received is low, we know that we have sufficient moisture. So we'll just print a message, something like that, onto the terminal. But else, we know that moisture is low, so we need to output a message to the terminal to that effect. Low moisture irrigation needed, for instance. So now that we have declared these three parameters that we're looking at, humidity, well, relative humidity, temperature, and soil moisture in the form of those three variables, all that's left to do is for us to print those values to the terminal on the Raspberry Pi. So I'll tell it to print, let's say sensor data, and I'm going to use a formatted string like so. Humidity is open curly brace, So that whole string dot format, and that is essentially it for a basic script that's going to look at printing these values out on terminal. If we try to run it, run sense_test.py. Oh, well, that's, of course, we'd want a period instead of a comma. Sort of goes without saying. Let's try that again. We want to also save after we make changes. That always helps. One last time. There we go. Ooh, 166%. That can't possibly be right. So the concept is that we've now printed a humidity value, a temperature value, and an opinion from the moisture switch output, and we've printed that directly to terminal. What we could do if we want this to run continuously, to put it in an infinite loop. So we could say while true, and let's just let it rest for a moment by time.sleep, and for a period of 5 seconds. Now we save that and run it again. Well, of course my indentation must shift. Okay, with indentation fixed, let's see what else it throws at us. Nope, looks to be happy this time. So it's the read retry, tries the DHT sensor for a reading every second, and I think it's either 12 or 15 times, and as soon as it's done with that, then it takes an output. Oh, I think I see what's happened here. It's just going to while true. Right, so because I didn't make my print part of the situation over here, it's not seen as being part of that while loop, and therefore before it even gets to the print, it's while true looping, which is essentially just an infinite loop. Again, it'll take a couple of seconds until it gets a reading, and then it'll rest for 5 seconds and try again, and essentially keep giving us readings until we forcefully keyboard interrupt or quit the program. Or not, I mean, there's also that. There we go, sensor data. Waits 5 seconds and gives it to us again, waits 5 seconds. So this way it essentially keeps printing this data every 5 seconds until we forcefully quit the program. Obviously our moisture and temperature situations remain the same, but 164% is not not a good relative humidity result. But point being, this is now correctly interfacing with the Raspberry Pi GPIO. And that's essentially it. If all you need is just to see the values from your sensors on the terminal, then that is the entire block of code. It might also be useful to have user alarm. You don't get to check in on the crops physically regularly. That's precisely what this is for. So we're going to look at a basic email notification as well, to be sent right out of the application here as soon as we see a low moisture condition. Until then, keep learning things the hard way.